Welcome on a tutorial on how to develop an application using the NITH framework. NITH is an open source software and hardware ecosystem for the creation of accessible applications for users with hand impairments, which use interaction channels like, for example, head movement, facial gestures like eye blinking, mouth aperture, etc., or for example, breath pressure, and others that we will see next in this tutorial. It is mostly written in C#, and while portings to other languages may come in the future, my advice for now is just to develop under Windows operating system. Let's see some use cases. NITH can be used to make all kinds of hands-free application. For example, computer control tools, for example, to replace the mouse and the keyboard. Specialized communication tools, like specialized keyboards. Creative tools, for example, I use NITH to make hands-free musical instruments. In general, it can be used to make any interaction solution which exploit unconventional interaction channels. The target users are many, for example, people with ALS, quadriplegia, and other kind of hand impairing conditions. The philosophy behind NITH is to try to make things as much as possible simple, modular, economically affordable, and open, so the developers can achieve high customization possibilities and can prototype new solutions in a small amount of time. An important insight that I've got from my rather short experience in assistive technologies development is that each individual have a very different set of abilities, and sometimes they evolve over time. So customization is crucial, and the ability to make a system that can adapt to the possibility of each individual is very important. And this is exactly what the NITH framework tries to enable the developers to achieve. In the NITH framework, it is crucial the concept of interaction channel. We will see that a person that cannot use their hands to interact with the computer actually has a variety of other possibilities. For example, they can use the eyes, or the voice, or the whistle, or the breath, or the head rotation to interact with the computer. Each of these interaction channels have been subdivided in different parameters, which are like different degrees of freedom. For example, we can see in the top left corner that from the left eye, we can extract the position of the eyebrow. We can get the height of the eyebrow. We can get the aperture of the left eye. We can see if the left eye is open or closed and its position on the 3D space. The main entry point for our data are, of course, sensors. And NITH includes a small collection of do-it-yourself solutions. For example, you can see here a teeth pressure sensor, a breath sensor, and a head tracker. Those are made such that someone can easily replicate them at home using do-it-yourself materials and Arduino microcontroller boards. But of course, we don't have to reinvent the wheel. Commercial sensors already exist, like for example, webcams on our laptop, or cameras in our phones, and accelerometers in our phones. So NITH includes also a collection of wrappers, which are basically pieces of software that turn commercially available sensors into stuff that actually extract data from our movement. For example, in this image, we can see the NITH webcam wrapper, which can be used to detect face movement features. Besides sensors and wrappers, the NITH library includes a variety of tools, like for example, software libraries and other development tools. Speaking about libraries, NITH library is the main core part of the NITH framework, which provides parsing, input parsing capabilities from NITH sensors and wrappers, and some basic tools for data manipulation. NITH emulation is an extension which provides capabilities for basic input-output emulation, for example, to receive and send keyboard and mouse events. And then we have NITH DMIs, which is another extension which I used a lot in my research, which provides tools for the development of accessible digital musical instruments. Development tools include various components, such as a graphical user interface called NITHtester to test new NITH sensors and NITH wrappers, so that the community can make new ones. Then we have an example application to see the source code, a basic template for new applications, and a ready-made application which provides mouse emulation capabilities through head, blink, and mouth tracking. A good way to understand how NITH works is to make a really simple application. So let's get to the tutorial part. By following this tutorial, we will make a really simple application that detects and visualizes head rotation on the U-axis and detects eye blinks. And we will do that through the NITH webcam wrapper. So you will just need your webcam, for example, from your laptop or a simple hardware webcam. Then the application will use the left eye blink to emulate left mouse button events, such as a click and release. In order to properly follow this tutorial, you will need an installation of Visual Studio with C# and .NET development tools, and an installation of Python 3.12, which will be necessary to run the NITH webcam wrapper. Since at the time of the application of this tutorial, NITH framework is only compatible with Windows operating systems, you need to follow this tutorial on a Windows machine. First of all, clone this repository or download the contents in a zip file, and then launch the download materials of that script. This script will download the NITH webcam wrapper, which will turn the webcam into a sensor, NITHtester, which is a graphical user interface application that we will use to test if the NITH webcam wrapper is properly sending data. A set of 3 libraries, which are NITH library, NITH emulation, and NITH DMIs, and NITH template, which is a blank project for Visual Studio that we will edit and we will use as a base for our project. Before beginning with the tutorial, you have to install and run NITH webcam wrapper. Remember to first install Python 3.12, and you can use the included automatic installation scripts that you find in the folder and run the program, and just select the webcam when prompted. While the NITH webcam wrapper is running in the background, please open the NITHtester application, set the input to UDP port, make sure that the port is set to 2100, and press connect. We'll hopefully see all the data coming from this NITH webcam wrapper visualized. And the nice test to make is to enable the head tracking visualization tool. If hopefully everything is working properly now, we can get to the coding part. But before putting our hands on the code, I think it's better if some of the metaphors and philosophies behind the NITH library are actually understood. The NITH framework suggests a coding philosophy to maintain a clean and organized structure, a principle you will see reflected in the NITH template project. All the main modules and components are organized inside the rack, which is a static class, which acts as an organized shelf where all the primary modules and components are kept. When a connected sensor or a data wrapper transmits information to your application, it arrives formatted through a standardized communication protocol called the NITH protocol. This ensures that all incoming data speaks the same language. Within your application, a path receiver acts as the initial gathering point, managing the flow data from all connected sensors and wrappers. From here, the raw data is passed to a NITH module. This module can perform initial data cleanup and preparation before sending the refined information to a series of behaviors. They define the actual actions and control you want to execute using that sensor data. Also housed within the rack is the mapping module. This component is responsible for remembering data associations and managing the wiring that dictates the program's internal logic. Alongside it, the rendering module takes charge of the graphical user interface, managing everything the users will see on the screen. These classes, by the way, are empty and totally optional. You can decide not to use them. For those with a programming background, this architecture creates a logical separation, similar to the well-known model view controller pattern, to make things more modular and manageable. Let's see how the NITH module works. Let's say, for example, that we have the NITH webcam wrapper, which is passing raw data to our NITH module in this form. The first thing that the NITH module do is to parse the data into a more convenient data structure. Each sample of this data is then passed through a list of preprocessors. Preprocessors actually define how we preprocess data before doing something with it. For example, we can do smoothing. Or like, for example, if we have a noise signal, we can proceed to data smoothing. Or inside the NITH library, we will find a list of ready-made preprocessors. Like, for example, for the NITH webcam wrapper, we have a preprocessor that proceeds to blink extraction. Blink data does not come by default inside the raw data. This is because blink calibration should happen at real time. The preprocessed NITH data is then sent to a list of behaviors. Behaviors are stuff that we define to specify what we are actually doing with this data. For example, inside the behavior, we can define that the left eye blink will activate a left mouse button, or the head rotation will control mouse cursor movement. All of this is defined inside these classes here. Okay, we can start here. First of all, let's open the NITH template solution at Visual Studio. When we will open the NITH template solution, we will have and find inside these three projects, the NITH library and the NITH template. Okay, first of all, rename this project into something that we like. Then we will have to open the rack class inside the NITHtutorial and declare these two members here, the UDP receiver and the NITH module. As we said, the UDP receiver will be able to detect incoming messages from the UDP port, and the NITH module will be able to process them. Inside the rack class, we also find the mapping module and the rendering module. The mapping module is, as we already mentioned, it is responsible for the logic behind our system, and the rendering module will be responsible for the graphical user interface rendering. After this, we should head to the default setup. And this class contains the setup method, which will be called upon application startup. We already see that there are instructions to instantiate the modules, mapping modules, and rendering module. And we can add the instantiation of the NITH module also. Then we should add also the initialization of the UDP receiver to the port 2100, which is the default port of the NITH webcam wrapper, and connect the UDP receiver with this method in order to start collecting samples from this UDP port, and add the NITH module as a listener here to the UDP receiver. This preprocessor will give us access to the Boolean values for blinking and mouth aperture. And this happens via an automatic calibration process where the NITH preprocessor continuously updates the maximum aperture of eyes and mouth and evaluates the current aperture against a threshold to decide if the eyes and mouth are open or closed. We can change this behavior and access to a manual calibration mode, like this. And we can switch to automatic continuous or manual calibration, but for now we can stick with the default method, which is automatic continuous. Then we are going to add the UDP receiver and the NITH module to the disposables list, so the related resources get released upon application shutdown. Now we head to the main window class, where we will design a graphical user interface. We are interested now in making a really simple application that detects the head movement in the yaw axis and blinks. So we reach the toolbox here, and we draw a progress bar. And a pair of rectangles. We should tweak a little bit the progress bar to put a name, so we can reference it inside the code. PRP head movement. And then we should put a minimum and a maximum of like -50 and +50. This is because the yaw movement that we will detect is centered on 0. And the rectangle also, the rectangles should have a name. RCT left blink. And we can put the other as RCT right blink. And we can also put a default field, coloring it gray. And again for the other one. So in order to use the data coming from the NITH webcam wrapper, in order to steer this progress bar according to head rotation and to change the color of these two rectangles according to eye blinking, we can make a pair of NITH sensor behavior to add to the NITH modules. So the first one will be behavior webcam to progress bar here. And we can make it by pressing add new item like this. So now we can proceed to the implementation. The first thing we have to do is to inherit from the interface a NITH sensor behavior. And we can use the automatic suggestions to implement the interface, and we will get this method here called handle data. It receives a data package called NITH sensor data. And the first thing that we can do before implementing this data, this handle data method, is to declare a list of parameters that we are going to use, that this behavior is expecting to work. And this list will contain the NITH parameters dot head position yaw. The NITH parameters there contains all the list of complete list of possible parameters that are coming from NITH sensors. Now we are going to use just the position on the yaw axis. We can also make a placeholder here for the EO value. Okay. And then we are making a check inside this handle data method to check if the NITH data package contains the expected parameters here in this list. If this is the case, we proceed to extract the head EO using this formula, NITHdata.getParameterValue. We will get the parameter value head position EO from the NITH data, and then we have to extract the value, and if you use this, the value is automatically parsed as a double. Then we can exploit our mapping module to save this value here. Head position EO equal head EO. We head to the mapping module, and we can put this set of values here, the head position EO, and a Boolean with left eye is blinking, and a Boolean with right eye is blinking that we will use next. So now we get to the second behavior to implement, which is blink-based color change. And this time we will inherit from this abstract class called NITHBlinkEventBehavior. This is abstract class used for blink detection. It is a NITH sensor behavior again, but with some nice perks. If we implement it, we just get this list of behaviors to override. We can remove the not implemented exceptions in the body of the methods. Each of these events will be triggered upon, for example, double closure of both the eyes, opening of both the eyes, on the event of opening, on the event of left eye closure, left eye opening, right eye closure, and right eye opening. And in this case, we just modify these methods in order to implement this code here, which is simply switch flipping on the mapping module. We change the value of left eye is blinking and right eye is blinking according to closure and opening. If their left eye is closed, so the left eye is blinking. If the left eye is open, then the left eye is not blinking. Simple as this. Now we simply have to get back to the default setup and add these two behaviors to the NITH module, like this. Sensor behaviors is a list of behaviors contained in our NITH module, and these are our new classes. So since now we have all these values in the mapping module that will get updated at every sample, including the head position EO and the left eye is blinking, right eye is blinking, we can go to the rendering module and update this dispatcher update method with this code here. So we will steer the progress bar head movement value according to the mapping module head position EO. In the rectangle color, the rectangle's color will follow the left eye is blinking and right eye is blinking. If the eyes are blinking, they will become green. otherwise red. So if we run the program now using the debug mode or without the debug mode, and we run the NITH webcam wrapper in the background, we will find out that the graphical user interface will respond to our head movement and eye blinking. So now we will add an interesting feature to our program, which is the possibility to use the left eye blink to emulate left mouse button clicks. So we add as an existing project the NITH emulation library, which we cloned from GitHub in the beginning of this tutorial. Inside the mouse folder, we'll find a set of mouse emulation tools, but the most important class for now is the mouse sender, which contains a set of methods which we can use to emulate mouse events. Then we head back to the NITHtutorial project, and we add a new behavior called like this. We inherit from the abstract NITH link event behavior class, and we implement the abstract class. And this time we will use the close and left open methods in order to send the mouse clicks like this. Now sender dot send mouse button event, and as a flag we will choose the left down on left eye closure, and we will do the same for the left open, but changing the mouse event to left up. Finally, we add the default setup class again, and we add this behavior to the list of sensor behaviors inside the NITH module. If you run the application now, you should be able to use your left eye blink to emulate the left mouse button. So, in conclusion, let's see what we have achieved so far. We have developed an application which is capable of head and blink tracking and provides us with the possibility to perform mouse clicking through our blinks. But hopefully, we have learned the basics of the NITH framework, and we are able to build new applications using the same tools. And now, you can try one of our exercises to make sure to put into practice what you learned. And you can find some prepared exercise on our GitHub repository called NITHtutorial. And you can find that link in the description of this video, as well as the other materials we provided. To do so, you have to clone the NITH template again and check on the instruction to make this new applications. We hope that you found this tutorial helpful, and if not, or if you have any constructive comment or observation, please let us know in the comments below. Bye-bye. left